Hello. Today we are going over notes 8.2, angles in standard position. So again, this is our trigonometry unit. So an angle in standard position, the vertex is at the origin, the initial ray is on the positive part of the x-axis, and the terminating ray. So here's an example of an angle in standard position. So here's the vertex, here's the initial side, and then you have a terminating ray. So this is the angle that we'd be looking for. We're going to see that that's going to be called what we call theta. Right? So this symbol, right, is called theta. We're also going to see this symbol with like a little apostrophe. That is what we call theta prime. So it's the Greek letter theta. So positive angles are generated by a counterclockwise rotation from the initial ray. So you go to your left. A negative angle is generated by a clockwise rotation. So you go to the right. So usually all of our angles we've always dealt with, you guys are usually from like 0 to 180. But now we're on that coordinate plane, so our angles can go all the way to 360. That's around one time, and they can keep going. But again, it's kind of like a circle. We're going counterclockwise for positive and clockwise for negative. So theta is the original angle in standard position. Sometimes we're going to be finding sine, cosine, and tangent. You can't find that by looking just at theta. So we're going to use what we call a reference angle, theta prime. It's the acute angle formed by the terminal side of theta and the horizontal axis. So here is theta, right? This is theta. This would be theta prime. This is theta. This angle here would be theta prime. So we're going to see that sometimes it's easier to find and use theta prime than theta. And what's nice, though, is they're both going to have the same sine, cosine, tangent ratios, which is helpful. So again, positive angle is going to the left, right, counterclockwise, and then this one is to the right for a negative angle. And again, when you see this symbol, you're going to see me talk about it. This is theta. And then with the apostrophe, that's theta prime. So here's an example. So if you're in quadrant 1, remember the quadrants go, right? When you're looking here, you have quadrant 1, quadrant 2, quadrant 3, quadrant 4. So when you're in quadrant 1, right, this is 60 degrees. That's theta. It's also theta prime. It's its own reference angle. Okay? Here, this is theta. This would be theta prime. So it's a 120 degree angle. The reference angle is 60. It's the distance from that ray to the horizontal axis. For us, the horizontal axis is always the x-axis. So here you go, quadrant 3. This is theta. 60 degrees would be theta prime. So it would be this angle here. Right? It's from where the ray ends, where the angle stops, that terminating ray, to the horizontal. Here, this would be theta. 45 degrees would be theta prime. That's the reference angle. So you have to understand what quadrant you're in to help you figure out the reference angle. And we're going to use those reference angles a lot. Because we're going to see as we move on, I'm going to ask you, what's the sine of 315? And you're going to be like, I have no clue. But you're going to find out, okay, it's the same thing as the sine of 45. And that you're going to be able to tell me. So the reference angle is always positive and measured from the terminal side to the x-axis. So this is always a positive angle. So example, sketch the angle in standard position. What quadrant is the terminating ray? And find the reference angle, theta prime. So you're going to draw a coordinate plane. So this is 0 degrees. This is 180 degrees. So 310 would be over here. So you would be in quadrant 2, right? That's where the terminating ray, or sorry, not quadrant 2, quadrant 4. Okay, so what's the reference angle? So what is this angle right here? Well, this is also 360. So if you're at 310 to 360 would be 50 degrees. So that would be theta prime. It's always positive. It's always from where the angle, the ray stops to the horizontal. Okay, negative 200. Right, remember it's negative, so this is 0. This would be negative 180. So you would be in here. So you would be in quadrant 2. And if this is negative 200, the reference angle is this angle here. So if this is negative 200, that's negative 180. Theta prime would be 20 degrees. It's not negative 20, it's 20 degrees. Reference angle is always positive. And again, we're going to start using these reference angles later to help us find sine, cosine, and tangent of these angles. All right, 500. Okay, so this is 0, this is 180, this is also 360. So I go all the way around once, that's 360 degrees. So this is going around more than one time. So how much more? So another 140 degrees. So it doesn't quite get back over here. So there you go. So if you do 360 and add another 100 degrees, right? Sorry, another 180. That would be 540 if you made it all the way over here. So we don't make it quite to 540. We don't make it around 1.5 times. We make it to 500, right? So this angle here, right, you would be in quadrant 2, and theta prime would be 40 degrees. Because down here, around 1.5 times is 540 degrees. We don't get quite to 540. We are at 500, so it's 40 degrees reference angle. Okay, negative 320. So now I'm going clockwise. So this is 0. This is negative 180. This would be negative 360. So I'm here. So I'm in quadrant 1. And theta prime, right, 20 to 360 is 40 degrees. So the reference angle is 40. And what you're going to start to see is when we start to do this more, those reference angles are always going to be 30, 60, and 45. And we'll go back to our special right triangles. So 250, so 0, 180, right? This is 270, so I'm in here. So I'm in quadrant 3, theta prime. This is the one where most students get in trouble because it's back to the horizontal. So it's this angle here. So this is 250. So this is, right, 70, right? It's back to 180. So that's where most students make the mistake, is they want to go to the 270. It's not. It's to the horizontal. That's the reference angle. Right, negative 800. So this would be 0, negative 180, negative 360. Right, so I go around one time. Right, remember it's negative. Negative all the way again. Right, that would be negative 720. So I don't make it back here. So I'm in quadrant 4, theta prime. So negative 800, negative 720. So I'm finding this angle here. That would be 80 degrees. So remember, Negative, you're going clockwise. Positive, you're going counterclockwise. Quadrants, again, right? 1, 2, 3, 4. Okay. Wait, going to the next page. So now going back to our unit circle, which we'll be seeing more of. Remember, unit circle is because it has a radius of 1. So we want to try to find the missing coordinate. So we're going to have to get a little creative with this to find the missing coordinate, and then we're going to find sine, cosine, and tangent. Okay. So we're trying to find the angles for theta. We're going to use the reference angle theta prime. So I'm trying to find sine, cosine, and tangent of that angle, but I'm going to use theta prime because it's going to be easier. So this is 1, right? This is negative 8 over 17, so that would be this part here. So I'm trying to find this distance here, because that would give me that coordinate. So I could do Pythagorean's theorem, right? But 1 and 8 over 17, that's kind of challenging to square. So what I have right now is I have a triangle that looks like this. 1, and I have 8 over 17, right? So what I'm going to do is I don't want the fraction. So I'm going to make this triangle bigger. So I'm going to use this triangle and use a similar triangle that's just going to be bigger to help me solve this. So how can I get rid of the fraction? Well, what I'm going to do is I'm going to take my triangle and I'm going to multiply it by 17. I'm going to make it 17 times bigger. Why would I do that? So by making this triangle bigger, right, now this becomes 17. These reduce, and now you just have the negative 8. And the negative is not the length, it's just a direction. So we can ignore the negative for the moment, but the negative just means a direction. So now it becomes a little bit easier to do Pythagorean's theorem. Right? Now it's just, okay, 17 squared equals whatever you want to call this, a squared plus 8 squared. So 289 equals a squared plus 64. Or you could recognize that this is a Pythagorean triple. So you get 225 equals a squared. So this is 15. So it's 15. So now I know all three sides. So I multiplied, right, by 17 to go to the big triangle. So if I want to go back, I'm going to divide by 17. So this would be 15 over 17. So the missing coordinate is 15 over 17. So again, I multiplied the blue triangle by 17, made it 17 times bigger to get the green triangle. Did Pythagorean's theorem. They're similar triangles. So if one's 17 times bigger, to get back to the other one, I could divide by 17. So that's why I get 15 over 17. And that was the triangle, the height I was trying to find. So that's the missing coordinate, 15 over 17. Now, we still haven't found sine, cosine, and tangent. And this is still theta prime. This is theta prime. So I'm going to find sine, cosine, and tangent using the triangle that I'm tracing in red, the big one. Okay, so sine of theta, which is the same thing as theta prime. Sine is equal to the opposite side, so 15 over the hypotenuse, 17. Cosine is equal to the adjacent, so that would be 8 over the hypotenuse, which is 17. And then tangent of theta is opposite, which is 15, over adjacent, which is 8. So opposite and adjacent. So that was part B. I used the bigger triangle. Okay, so if we go to the next example here. So now I'm trying to find this missing coordinate. So I have this little triangle. So here's theta prime. So I'm trying to find this angle here, theta. Well, what I'm going to do is use theta prime to help me. So this is 1. Negative 3 root 5 would be this. So I'm trying to find this missing value here. So same idea. I'm going to make a bigger triangle. Use a different color. So I'm going to multiply by 5. So this would be 5. This would be -3. Again, we don't need the negative. That just means it's going down. So I'm going to multiply everything, every side, by 5. So now my blue triangle is 5 times bigger. This is still theta prime. So now I could do Pythagorean's theorem, or recognize it's a Pythagorean triple, so the missing side is 4. So I multiplied by 5 to go to the big blue triangle. So to go back, I'm going to divide by 5. So this would end up being 4 over 5. So the missing coordinate is 4 over 5. So to go from the big triangle back, I'm going to do opposite of how I went from red to blue. I multiplied to get to the big triangle, so then I'm going to divide to go back. So now, same idea. Find sine, cosine, and tangent. So sine of theta is going to be the opposite over the hypotenuse, so 3 over 5. Cosine of theta is adjacent, and then tangent of theta, right, is opposite over adjacent, so 3 over 4. Now, I did forget on the last example and about the signs. I'm going to go back to that. So notice we went down, so this should be negative. So anywhere there's a 3, that should be negative. So those two fractions should be negative. So I forgot to do that here with the -8. So anything with a negative should be a negative fraction. Because the negative, again, it's not a distance, it's a direction. So I went left, so this should be a -8. I went down, so that should be a -3. So sine, cosine, tangent are very useful to us. And right now, most of you are knowing sine, cosine, tangent is opposite over adjacent, hypotenuse, right, and adjacent, which is fine. That'll help you in most of the problems. But sometimes that's not going to help you. You won't know what's the opposite side or what's the hypotenuse. So we're going to talk about sine, cosine, tangent in a different way. So we're going to talk about it on a coordinate plane. So just a reminder, r is going to be always positive because it's the radius of a circle. So we were just working with a circle, in our case the unit circle. The radius was 1 on the last two problems. So we're going to talk about sine, cosine, and tangent in terms of x, y, and r. So x would be, right, your x value, how far you went left and right. Y value would be how far you went up and down. And r would be your radius. So y is the opposite of the triangle. X is the adjacent. R is the hypotenuse. So sine of theta, right, would be opposite over hypotenuse. So that's why it's y over r. So again, this is for angles in standard position, which we're going to be working a lot of. Angles on a coordinate plane. Cosine is adjacent, so that would be x over r. And tangent is opposite over adjacent, so y over x. So this is another way to think of sine, cosine, and tangent, right, in terms of the coordinate plane, because we're going to be working on the coordinate plane a lot. You're going to see you don't always have a hypotenuse or opposite or adjacent leg. Okay. So we have our 30, 60, 45. Right? So 30 degrees. Right? If this is 1, right? This would be 2. This would be root 3. Right? If it's 45, if this is 1, this is 1. This would be root 2. 60, if this is root 3, this would be 1, this would be 2. Okay. So again, how did I get those? 30, the opposite leg, I'm just saying if it's 1, and you're going to see that it's 1, then the hypotenuse is twice as big. And then the long leg is root 3 times 1. And if these are 1, right, this is a times root 2, so 1 times root 2 is root 2. And you would have saw this when we did worksheet 8.1 and when we get to 8.2 on this worksheet, you'll see this a little. So find the acute angle theta, all right, that satisfies the following equations. So use your special right triangles. So sine of theta equals 1/2. So I'm looking out of those 3 triangles, right? 1 over 2, right? It's where is sine is x, sorry, y over r. So where is the adjacent, sorry, the opposite side 1 and the hypotenuse is 2? Which triangle? So that would be 30 degrees. So this answer would be 30 degrees. So it's saying sine of theta equals 1/2. So the opposite side is 1, the hypotenuse is 2. Where does that happen? That happens at the 30-degree triangle. Right, if you're looking at B, right, I want to make it look like A by adding 1 and then dividing by 2. Okay, so cosine, right, that would be the hypotenuse and the adjacent side, or x over r. So where does that happen? Oh, that happens at 60 degrees. Right, tangent of theta, right, we can add 7, divide, equals 1. So remember, tangent is y over x, so 1 over 1. Oh, that's 45 degrees. Wait, D, this is the tricky one. So root 3 over 3. So that would be, right, root 3 over 3 would be root 3 opposite over adjacent, y over x. Well, there's nothing like that up there. Right? Root 3 means it's going to be 30 or 60, but I don't know which one. So it's not 45 because it's not root 2. So what happens was, like if I took a side and got 1 over root 3, we went over this in unit 6, you'd have to rationalize it, right? You'd have to multiply by root 3 over root 3. Well, what's happened is they've already done that. So we got to go backwards. We got to de-rationalize it. We got to get back to where there's a radical. So to do that, same concept, you're going to multiply by root 3 over root 3. So in the numerator, you're going to get root 9, and then 3 root 3. And then this is 3 over 3 root 3. The 3's reduce. So it's 1 over root 3. So now, instead of writing root 3 over 3, y is 1. The adjacent is root 3. Oh, look at that. That's 30 degrees. So sometimes you're going to have to work backwards. That doesn't happen very often. But if you go write your ratio of your two sides and you can't find it on one of those 3 triangles, then probably what happened is they already rationalized for it. So you got to de-rationalize it. So you literally just multiply by whatever radical is in the numerator. It's just going backwards from what we did in unit 6. So again, sine, cosine, tangent, opposite over adjacent, all of that. But also now you want to start thinking about it in terms of standard position, because we're going to be on a coordinate plane a lot. So you want to start thinking about sine as y over r. The how far up over the radius. X over r. How far over and the radius. And then tangent is y over x. Because that's going to start to be helpful when you're working in standard position, which we will be doing a lot of in this unit. Please make sure you answer the essential question with a 3 to 5 sentence summary. Once you've done that, then you're done with your notes. Have a wonderful day.